Hi guys! Today we're going to look at how to procedurally generate a perfect maze. We're going to do this by using a simple algorithm. The algorithm starts by creating a grid of cells representing the size of the maze we want. Then it begins creating the maze from the top left cell. It finds a random unvisited neighbouring cell and knocks down the wall. Then it moves on to this cell and does the same again. It keeps going until there are no unvisited neighbours at the current position. There's nowhere to go from this cell, so it goes back the way it came and tries each cell until there's a route it can take. It keeps doing this until every cell's been visited exactly once and the maze is finished. Okay, let's get started by opening Unity Hub and creating a new 3D URP project. Once the project opens, we'll create a plane for the ground. To do this, we'll click the plus button on the hierarchy and select 3D Object, Plane. We'll set the scale of this to 1000 on the X and Z axes. Then we'll reposition the camera to get a good view of the scene from above. We'll select it in the hierarchy and set the position to 10 on the X-axis, 20 on the Y-axis and 14 on the Z-axis. We'll also set the rotation to 80 on the X-axis and minus 180 on the Y-axis. Next we'll change the colour of the floor. To do this, we'll click the plus button on the project panel and add a new material. We'll call this Floor Material. We'll drag this onto the plane to assign it. OK, next we'll create an object to represent one cell of the maze. We'll click the plus button on the hierarchy and add an empty game object. We'll call this Maze Cell. Then we need to add child components for each of the cell walls. We'll right-click the maze cell and add an empty game object. We'll call this Left Wall. Then we'll right-click on this and select 3D Object, Cube. We'll call this Graphics. We want the wall to be narrower than this, so we'll set the X scale value to 0.2. We'll also increase the length by setting the Z scale to 1.2. This is so that all the walls overlap and we don't get gaps in the corners. Next, we'll change the colour of the wall. To do this, we'll click the plus button on the project panel and add a new material. We'll call this Maze Material. We'll drag this onto the wall graphics to assign it. Then we'll change the colour of the material to red. Let's select the graphics object in the hierarchy again. We have the appearance of the wall sorted, but we're using a non-uniform scale. This can cause unexpected issues with collisions. To fix this, we'll remove the collider from the graphics object. Then we'll select the parent object and add a box collider component. As this parent object has a uniform scale, collisions will work as expected. We'll adjust the size of the collider to match the size of the wall by setting the size to 0.2 on the X-axis and 1.2 on the Z-axis. Now we just need to move the wall to the left of the cell by setting the position to minus 0.5 on the X-axis and 0.5 on the Y-axis. Next, we'll create the other walls by cloning this one. We'll right-click the left wall and select Duplicate. We'll rename this Right Wall. Then we'll change the position to 0.5 on the X-axis. We'll duplicate the left wall again and rename it Front Wall. We'll change the position of this one to 0 on the X-axis and 0.5 on the Z-axis. We'll also rotate this by 90 degrees on the Y-axis. Then we'll duplicate the front wall and rename it Back Wall. We'll set the position of this one to minus 0.5 on the Z-axis. Now we have all the walls for the cell. The final thing we'll add is a block, to be displayed if the cell hasn't been visited by the maze generator algorithm. To do this, we'll duplicate the left wall again. We'll rename this unvisited block. We'll set the position to 0 on the x-axis. Then we'll select the graphics child object and set the scale to 1 on all axes. This now hides all the walls of the cell. We also need to resize the collider, so we'll select the parent and change the size of the box collider to 1 on all axes. That's all the components of the maze cell created. The maze generator algorithm will need to be able to disable these components to knock down walls and create the maze. We're going to create a script to help with this. We'll click the plus button on the project panel and add a new script. We'll call this maze cell. We'll drag this onto the maze cell object to assign it, and then we'll double-click to open the script in the editor. We'll start by deleting the default methods. Then we'll add a serialized field for each of the game object components of the cell. First we'll add the left wall. Then the right wall, the front wall, the back wall, and the unvisited block. Then we'll add a Boolean property to keep track of whether the cell has been visited by the maze generator. Next, we'll create some helper methods. We'll create one called visit. This will be called when the cell is visited by the generator algorithm. In here, we'll set isVisited to true. We'll also deactivate the unvisited block so that the walls become visible. Then we'll add helper methods to clear each of the walls. We'll start with the left wall. In here, we'll simply deactivate the left wall. Then we'll do the same for the other 3 walls. That's it for this script. Let's save it and switch back to Unity. We'll select the maze cell in the hierarchy. Then we'll drag all the components to the relevant fields on the script. Next, we'll turn this into a prefab so that the maze generator is able to create a grid of cells. To do this, we'll drag it into the project panel. Now we can delete the cell from the scene. The next thing we'll do is implement the maze generator algorithm. We'll click the plus button on the hierarchy and add an empty object. We'll call this maze generator. Then we'll click on the Add Component button and add a new script called Maze Generator. We'll double-click the script to open it in the editor. We want the generator to be able to create a grid of maze cells, so we'll add a serializable field to hold the prefab of the cell. We also want to be able to configure the size of the maze, so we'll add fields for the width and depth. To hold the grid of cells, we'll create a two-dimensional array. We'll initialize this array in the start method using the specified width and depth. Next, we need to populate this array with maze cells. We'll create a loop that goes from 0 to the width of the maze. Inside this, we'll create another loop that goes from 0 to the depth of the maze. In here, we'll instantiate an instance of the maze cell. As each cell is exactly 1 unit in size, we can position it using the loop variables to place each cell next to one another. We'll set the rotation to quaternion identity to specify no rotation. Now we've created the cell, we'll assign it to the array. So this will loop through every position in the maze grid, create a cell and store it in this array. Let's save the script and switch back to Unity to test this out. We'll select the maze generator in the hierarchy. We'll drag the maze cell prefab into the field in the inspector. And we'll set the width and depth to 20. Let's press play to see how this looks. Now we can see we have a grid of maze cells. The next thing to do is carve the maze in this grid. Let's stop the game and switch back to the script. To allow us to see the maze being generated, we're going to make use of coroutines. If you aren't that familiar with coroutines, then we have a dedicated video on them where you can get more detail. We'll change the start method to a coroutine by changing the return type to IEnumerator. Then we'll create a new private coroutine method to generate the maze. This method is going to be called recursively to generate the maze and ensure every cell has been visited. To be able to do this, we'll need two parameters. One for the previous cell that was visited by the algorithm, and one for the current cell being acted on. The first thing we'll do in here is call the visit method on the current cell. This will make all the walls of the cell visible. Next, we need to knock down the walls between the previous cell and the current one. We'll create a method for this called clearWalls. This will take the previous and current cell as parameters. First of all, we'll check if there's a previous cell, as there won't be one when we're on the first cell. In this case, there are no walls to clear, so we'll just return. Next, we'll check if the position of the previous cell is to the left of the current one. If it is, we know the algorithm has gone from left to right. So we'll clear the right wall of the previous cell and the left wall of the current one. Once we've cleared the walls, we can return. Then we'll do the same for the other directions. We'll check whether the algorithm has gone from right to left and clear the relevant walls. Then we'll do back to front. Finally, we'll do front to back. Now we can call this method from the generate maze method. At the moment, this method just visits one cell. The next thing to do is move on to a neighbouring unvisited cell. We'll create a method for this. This will take the current cell as a parameter, and it will return a random unvisited neighbouring cell. The first thing we need to do is get all the unvisited neighbours. Then we can pick one of these at random. We'll create another new method that will return all the unvisited neighbours. Again, we'll take the current cell as a parameter. We want to check all the cells around this one to see which ones are unvisited. First of all, we'll store the X and Z position of the current cell. As each cell is 1 unit in size, these values also correspond to the index of the cell in the grid. We'll check if the next cell to the right is within the bounds of the grid. If it is, we'll get this cell and check if it's been visited. If it hasn't, we want to return this cell as one of the potential options. We can do this by doing a yield return of the cell. This adds the cell to the returned collection but will not exit this method, allowing us to continue and check in the other directions. We'll check whether there's an unvisited cell to the left. Then we'll check to the front. Finally, we'll check to the back. Now we've got a way to get all the unvisited neighbouring cells. We'll call this from the previous method we created. Then we'll use some link to order this list randomly. Let's add the link namespace at the top. Then we'll order by a random number. We can then use first or default to return the first one if there is any, or null otherwise. Now we can get a random unvisited neighbour. Let's call this from the generate maze method. We'll check whether the next cell is null. If it's not, we'll recursively call the generate maze method. We need to use yield return to call a coroutine. We'll pass in the current cell for the previous value and the next cell for the current value. This will cause this method to repeatedly be called, moving from cell to cell, until we get to the point where there are no unvisited neighbours. To be able to see the maze being generated, we'll wait for a fraction of a second after we've cleared the walls. We can do this by using yield return wait for seconds. Next, we need to start the maze generation. We'll call the generate maze method from the start method. At this point there is no previous cell, so we'll pass in null. For the current cell, we'll pass in the first cell from the array. OK, let's save this and switch back to Unity to try it out. We can now see the maze being created. You'll notice that it currently stops before every cell has been visited. This is because it stops as soon as it reaches a cell with no unvisited neighbours. We can fix this by tracking back and trying again from the previous cell. Let's stop the game and switch back to the script to do this. Rather than just visiting one cell, we'll change this to a loop that keeps going until there are no unvisited neighbours remaining. Because this is recursive, as soon as it reaches a dead end, it will drop back to the previous cell and try again. OK, let's save this and switch back to Unity to try it out. Now we can see it tracking back and visiting all remaining cells. While it's quite satisfying to watch the maze being created, it's more likely you'll want to have the maze already created when the scene loads. We can easily do this by removing the coroutines. We'll stop the game and switch back to the script to do this. We'll change the return types of the methods from IEnumerator to void. Then we'll fix any errors by removing the yield returns. OK, let's save this and switch back to Unity to try again. Now the maze is already generated when the scene starts. If we restart the game, we can see that each time we get a completely different maze. OK, that covers everything for this video. Hope you found it useful. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Leave any questions or feedback in the comments and subscribe and click the bell icon so you don't miss the next one. Thanks guys!